Hey, welcome back to the Dusty Console. It's been a while. Lots happened in the world since then. We've been a part of that as well. But we want to get back into things here too. Have a lot of time on our hands. One of the things that I really enjoy doing is having a lot of tools around the house, not only to fix the video game consoles, but also to fix other stuff. It can make anything from scrap, which is nice. But it can be a little difficult to get absolutely right here, but there's nothing wrong with trial and error with stuff there too. And even if you don't succeed, hey, everything was trash in the first place, so no harm, no foul, right? We get live in a society that throws a lot of stuff away. Well, it's not just video games too. For example, here I have a chair. Unfortunately has a couple of flaws in it. Overall, it's a good little thing for when we're sitting outside discussing games, but you can see here, these little plastic mechanisms, little pieces of plastic break, unfortunately, right there. And yeah, you could glue it up and, tape it up and have it live on a wing and a prayer. Well, why not make it better? And if you happen to have a mini machine shop at home for fixing consoles and doing electronics and an induction forge built, well, then you can start making cool stuff like this. Now, this isn't as great. The other side broke on this chair here, but you can see I've cast something out of aluminum that does the same basic job. A couple of screws through there. It's stronger than before. Might not fit exactly right, but it's perfectly good to keep your butt in place, fortunately enough. So today, I want to see if I can make a better version of one of these things, cast it, get something that looks a little bit nicer. Now, the old part is kind of still settled in there. First thing I want to do is actually remove this thing. But you see here, I'm putting this on there. And that should keep that from spinning. And now, since this is a little more open, I should be able to get around in here. Hold that steady. Dig some flakes out. And then you got a convenient little removal tool there too. So the part is out now, and you can see where it's broken. So yeah, now is where you would put some putty in there, refix it or something like that. But come on, we all know this plastic isn't going to last. So, but it is the shape that we want. So now over here, we can start deciding how we want to make our replacement piece. Well, the fact of the matter is, we just need a big old square piece of aluminum, and we can move that down to size. So make a big old square area here. Now these only have 2 operating areas, so we don't need to mill all of this area out. But what's important here is that we have this bar and this like little slanty area here that the thing moves into. Now you can see on my other creation here, well, it just so happened that I had a huge void in the mold there that was what turned out perfect to catch the arch of things there. I'm hoping to actually not have that this time because, well, I never seem to get lucky twice. Well, let's move on and start weighing out some aluminum and get something into the forge. So now we're in the forge area and little machine shop area. We'll be going through a lot of this stuff as we go through the process here. But before we get into the crazy forge stuff here, we need to know how much aluminum we need to melt to make a part that fills in all this area around here. So I got a bunch of scrap aluminum, but it's hard to tell how much you need to make something of this space. So now I got a little space here where you can see it's a little bit bigger than what the part is going to be, with a bunch of these graphite things off to the either side and a little something on the bottom of metal to kind of hopefully heat sink the heat away and not explode. Don't do this directly on stone like I did the other one. This is why that other one looks so gnarly there. Rocks might look dry, but there's a lot of explosive moisture in them when you pour molten metal on them. Learn from me. So, I got a few pieces of scrap here and I was kind of going through and I was found this. Looks like a piece of aluminum that's about the size of what I need, and if I imagine that fills in the space there. But, you know, it's kind of counterintuitive there. You have to imagine all of this getting filled in, so I want something at least this big of a chunk of aluminum. If you imagine squishing this in like it was Play-Doh, can it fill that whole square area there with a little bit to spare? Maybe not. So first, I'll turn on my scale, see how much this weighs, and that should be significantly. You know what? Actually, why don't we make it an even 100 or so? Yeah, a little bit more won't hurt us there. And we'll start melting that down. So let's load this into the forge here quick. So I don't want to screw up my mold. Put that over there safely. Feel free to leave comments on all this stuff that I'm doing that isn't exactly right here. I know there's a fair bit, but I'm going to clean things up before I get things heated up to a dangerous level here. So you see me dropping this. I have little crucibles of this size that go into this induction forge. So there's another ceramic little barrier thing in there that I have settled in there, and you can see the copper coils going around it there. So this is an induction forge. So high frequency AC goes through it, heats this guy up and the aluminum in it directly. It's not like your electric oven where those things are just going to glow red. It's going to just heat up the stuff that we need to melt. Of course, that leads to a problem. That copper is going to be making this hot, and it's going to get some of that heat back, and it could, in theory, flow into the electronics where we got all of this expensive stuff making all the fancy electricity to heat our stuff up. So if that got into there, it would begin to burn the board and melt things down. So fortunately, this tube is hollow. So you'll see I got these tubes hooked up to that. That's water that I got flowing through to my pump over here, which should pump water. And it's all a closed system, you know, coming and going. You see the two tubes down there, all the way to this random little thing of water that I got sitting in my shower. So hopefully that is just yellow because of the yellowish tile there. But I want to get it started out good and cold here. So I'm going to grab this ice, bring that over here, kind of throw it in there. And that'll get the water good and cold going through it, and just kind of give it a good head start. Make sure that it doesn't spontaneously boil, explode, and send hot water all over the place. So with that in mind, I'm going to put these guys in there, and I might be able to fit a good chunk of this. Actually, no, that's not going to go in there. Let me drop this in. So this we'll have to drop in later on. Keep that separate. Keep this insulated. Put a rock on there for good measure. And now clean the area a little bit. I should only have my tools. Oh, also what's really important is if the heat was just escaping from this, you'd be pouring a bunch of electricity into it, it'd be wasted. This is insulation, I believe spun stone or fiberglass insulation. Be careful when you cut this stuff, but it will keep all the heat inside there. And the only way it can escape, well, we have to have the little tubes going in there. But other than that, these rocks will begin to warm up and kind of radiate some of the heat back. Hopefully don't warm up so much that they explode like they did on this spot here, but this insulation should protect it. Got things semi-clean here. The WD-40 at least is a little further away than it usually is. I have 2 power supplies hooked up here, salvaged from various places and things. I got that there. Most of the flammable stuff is away, so I'm gonna actually turn this on. And we got all the fans and all that. So 120 volts. Now we're going to want to see the watts. So 50 5 watts. That's spinning these fans and this stuff there too. But get the so I'm gonna flick this on. And oh, all of a sudden we're just consuming a lot more than that. 600 watts. Hopefully that actually goes up a little bit. And then I want to check and make sure that my water's flowing. I hear that vibrating a little bit there. That should be okay. And don't forget, kids, don't do this at home. I'm an expert. Be safe. Don't be me. And one thing to check here, you'll see that our ice is already gone, but the water's still feeling cold. Obviously, if that gets steamy, you need to put some more ice in there, but it's big enough of a heat sink. This is small enough of a thing. It should be okay. So we're a few minutes in, trying to check things. You see the watt meter's gone up a little bit there, and that's good. That means science is happening here. Also important, open a window. There's just stuff here and there. I should be wearing a mask, but we got good flow today, so I think it's okay. Let's take a look just quick here to see if we have anything glowing. All right, set that there. That comes up here. Oh, I feel the heat. Oh, look, it's red, starting to melt already there. So we'll give that a few more minutes there, and then we'll try to get our last couple of items inside.
Always get something refreshing. You can do other stuff while things are cooking there and whatnot, but always set an alarm. I've made this mistake before, where I haven't set one of these. I get a little distracted, start playing some Half-Life or something like that. 20 minutes goes by, there's something funny smelling in your house. Oh crap! All of a sudden you got molten plutonium, it seems like there. So set this. Looks like we're going to be good in just a few seconds here. We'll run over there, add in a few more things, set another alarm for 10 minutes. In fact, when this goes off, don't let it shut itself off. Start it up over again so you have an alarm. Let's go.
Now that things are getting hot, we want to be a little bit better protected with some stuff here. So I like one glove that I can easily do things, and then another glove in case anything bad happens. In theory, this is a welding mitt. It can handle things a lot better. So there. Ooh, we're starting to feel a little warm. Oh, we got some glow. Yeah, we're starting to melt. So I'm going to drop this guy in, bloop, and this guy in, bloop. Come on, there we go. Put that all back and let things cook for a little bit longer here. So it's been about 5 minutes here. So one thing I've noticed that this is starting to go down from where it was before. Now, as the aluminum melts, it can take less, it goes from a solid to a liquid. It doesn't soak up as much of the induction heat. So that is actually a good idea of how hot and where your induction forge is at. So I'm going to take this and I'm going to poke at it and see if I can't get any of the slag off. So once more, I see the glow. Oh yeah, looks like we're getting good and melty. And, ooh, yeah. So I'd say that's good. We got some of that slag off there. See if I can't blip you off a little bit. And now I can dip this in. Ooh, I can touch all the way to the bottom. I'd say actually in just another minute or two, I'll let that heat up a little bit. Get things good and liquidy. And we'll be ready for the pour before the alarm goes off again here. Spend a few more minutes here. I got my tools ready. This guy to grab the crucible, lift him up and out. This guy to get around it so I can tilt it and pour it down. Gloves on for sure. You see now this has gone down just above 600 watts. Now if you are crazy enough to try this at home, every forge is going to be a little different. I've kind of gotten to know mine, what a molten pool of, how many watts my molten pools of aluminum take. But let's take this out and see. Yeah, we're looking good there. So get this guy around here. Lift you up. Get you secure there. Set you down. Turn you off. Oh no. That didn't work well at all. Ah, crap. Might still be good. Hey, live and learn, right? All right. So, you can see where I messed up here. Live and learn though, right? I poured this and it pushed away from the outside. I just kind of had these things sitting here, which is dumb. I have all of these great rocks that I could have just put up there and that would have been more than enough weight to stop it. But you can see how the metal has shrunk. I'm going to get in there and try to lift this guy up. Never touch the metal. Whoop. In fact, let me. Oh. Looks like it's sticking to the bottom there. And now, before you touch it, that it's not still hot. A little bit of water will help with that. Just let that sit for a while. Be extra safe. And so now we got some warm water. Do not make tea with this. So the slag, I did good and didn't pour on top of it there. I should have been more careful with that. That comes off. But unfortunately, with the sides popping out like that and the metal contracting, I got a big old hole in the bottom of this thing. So I was using an old hard drive plate I thought would be able to heat sink some of the heat away there. That was a bad idea. Only use proper sides for that stuff there too. The graphite mold is the way to go. So I'll see if I can't recover this, otherwise we'll try another one here. Always got plenty of spare scrap aluminum. All right, round number 2, right? So, live and learn. Use proper materials that can take heat for that. So I avoided doing it this way in the first place because I was afraid things are going to be precarious. But now, as I geniusly thought of 2 seconds after I made my mistakes, I'm using rocks and big pieces to put everything up into place here. So I'm pretty confident of that. So I'm going to actually load up the forge here. I still got the pump running to make sure that the cold water is circulating. Don't turn your pump off immediately when you're done. There's still a lot of heat in there. The water inside will boil and you're going to have a bad time. So let's put, I think I get a couple of these in there. That won't fit, but let's put that there, hit the super switch, pump is going, and yep, we're up to 600 watts again. Hopefully that'll rise and fall down to 600 watts again or so once everything is melted. Good times.
And I really need to follow my own rules and set the alarms. You know, you get frustrated when the milk goes bad, you start forgetting the little things, and that's when things go really bad. Oh, your wife yells at you. She ain't wrong. Yeah.
All right, the alarm went off. I got it reset again. So we made this. We want this to be smaller and, well, it'll have a whole lot less holes in it. Ooh, we're still at about over 600. I think it should be melty enough for us to add our next thing in, though. Let me move that. Oh, looks like we still gotta wait a little bit. Yeah, it's breaking apart, but it's gonna need a little bit more time before we can add our next thing in there. But hey, we're good to go again here. Some time has passed. We're back about down to 600 watts here. I'm hoping that's good enough here. I'm going to try to do a lot of stuff at once this time, since I've clearly learned so much from my mistakes before. So let's take a look here. Hopefully it's solidified enough. I can take the slag, melted enough, so I can take the slag off and then immediately take it out And yeah, we're looking good and melty there. So stir up the top, get some of that slaggy goodness off. Stir down there a little bit. Just try to get the guts out of it there. So let that sit, soak up a little bit more heat. I'm going to bring this tool in. Lift her up. Pump is still on. I made that mistake before. I turned the whole power to the system off, and I can feel that this is still really cool here, so I'm going to make sure that stays pumping. If I turn that off now, that red hot crucible in there would almost immediately boil the water in the system and cause a problem. Not a mistake I want to make 5 times. But this guy here, since I got a little bit better, I think we could do a little bit more dramatic of a meltdown here. So, whoop. Cool off, you. Cool off. It's been a minute for paranoia, even though once it's in the water, it gets cool pretty much right away, but just in case, dip the finger in, pull that out. Ooh, yeah, that's looking better. Now compare that to our other guy here. Yeah, that's a little bit better sized. This guy's kind of flooped out a little bit. Here, we got some thickness. There, we do not. So no holes, no nothing. This is something that we can machine down and make a part out of. Yay! Just kind of making error checking the process here. So I want the part to be a little bit bigger in each dimension so I can kind of flatten things out and get them to look nice. Not necessary, but you know, nice is nice. So you see here, it's not as big in that dimension as I would like it to be, but that just means we'll have some rounded corners here and there. That's all right. But let's just kind of trace things out here. Boop, 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 boop. And then I'll be able to measure that and see exactly, you know, what dimensions I'm working with, how much I can kind of lose, and where I need to take things off and start marking up this guy. But first, let's get him flat. Right?
Not quite like sandpaper, but, you know, maybe if I keep, no. 65 by 40. That's 51 by 46. So I'm going to need to make some new G-code.
Go to the proper directory, 55 by 55.txt. That looks right and pretty cool. So I got my little robot there. I am going to run this once. Uh-oh. Coming up is not connected. I may need to reboot.
Runs off a USB, and I kind of let this computer on all day, well, all week, all month. I don't get in here for projects as much as I'd like. But hopefully it comes back, and everything's plugged in right with the USB. Every IT guy knows first thing you gotta do is turn it off and on again, and check the connections.
And I need to tell it exactly where the center of this thing is to start. So I'm gonna try to get the corners in there as good as I can. Scribe a little line. Try to get the corners in there as good as I can. Scribe a little line. And unfortunately, it looks like the middle is pretty much, well, where that huge divot is inside there. So now I'm going to take it to my robot and get it in there. So this little guy needs to come out a little bit more. So Now I'm going to move in 1 millimeter increments. Try to get over. That looks like the highest spot. It's going to get a little noisy. I'm going to turn the tool on here. Different shirt, different day, right? So, been working on the machine here, and you can see here, it's looking pretty good. Let's clean that up a bit, a little WD-40. Shiny and greasy. We should be able to pop this out without needing to modify the drill bit there. So, see, we got a little divot in the center where the material shrunk, but I'm hoping this is still thick enough. And the sides, since the cast worked out pretty good, are pretty flat. Normally I'd try to flatten all of these out there too, but this isn't precise science here, so we should be all right. So, get a good old rag, clean up the rest of the gobbledygook. This came out a little thin. I would have liked it if it was a little bit thicker, but it's aluminum, not plastic. Hopefully it'll be strong enough still there. And so I need to make one of these. And so I know this part here with the angle there, that's going to be super important because that's where the bar is going to go through like that. So I kind of want to start with that there, and then I might need to hand file and get that in there right. But since this is going through, I can pretty much just kind of go over there, mark here, since it's square, doesn't really matter, and remove that material there, and then come back, try to make a little bit of an arc, see how that's going to fit, and then come back and drill holes here and here for that part to come through. And then I'm going to have to figure out, and I believe it's this thing right here, where the other pole is going to come in there. But for now, let's just concentrate on one thing at a time and get this thing out. Hopefully don't mess it up. Back at the little Praxton MF70 little mini mill guy. Basically Dremel with some precision little things. I got this vise mounted to it and custom aluminum soft jaws that I made. They're not very good, but I'm proud of them. So I got my target. I want to remove this area here to get started, and I'm going to try to use this little mill bit and actually go through and go and then out the other side there, so I can kind of do it all at once. It's going to get hot, there'll be a lot of material in there, and then if the aluminum melts, I got to back this up and I'll remove the aluminum. But I think if I keep it flat on the bottom of my vise there, alright, it should be good. Hopefully that will go through. Lock you down. And move you back ever so slightly. And we should be good to go. Let's set up, do a time lapse. This is going to take a while. didn't take as long as I thought it would. I can see I had to adjust the machine there a little bit, so I got that off a little bit there. Should have calculated how far out my machine could go. But now, I should have done this here too, we can start filing off the burrs. These will cut your fingers really nice and screw up your measurements. So let's just do that. A higher quality file that isn't a wood file would probably be better at this too, but you know, go with what you got, right? Surface there a little bit. Filing. Not the office kind of filing. Yeah, it's basically that. I'll get back to a little bit more on that, but there's the gist.
Probably need to get the chair out here too. So I wanted this like that, as I recall, and that will give me a little bit more room there. So
all these parts are copies of each other, but they get used in different ways. So here's my crappy part. And you can see what I did here is I actually tapped holes to go through there. We'll take care of that later. But here, you can see how this is supposed to go together. So I know that this part will go there like that. And then you see how I have things marked here. I'm going to remove this and then tap a hole there. And hopefully this will be strong enough. I won't need that surface spot in there. I won't have to do the more advanced thing. It ought to be, right? I mean, worked with plastic.
Going here, and then this guy is going to go there. And we're going to have to kind of force it. The chair's bent a little bit, but I think it'll be all right. So, taking our other piece to match up, we see that the hole naturally is right there, a little bit further out, I would say. So since we're tapping it and it wants to go inside, we're going to put it way on the outside there, let's say. So something where we got it just a little bit on the edge there. So we're going to drill a hole here, and we don't even have to go the whole way through because the bolt will tap it into itself there. This one will just go through on, and then the bolt will go the whole way through there, and hopefully won't interfere with this guy here. But we'll see. We can always cut it.
Bore blade. You're designed to work on wood, and I'm putting you through your paces. Say something about what we're going to need to do next here. So we'll get things fitted in there and see, but remember there's a little angle spot there. So now if you had the big bridge port and end mill stuff, that's where you could do one operation and go in there and take care of it. And technically with the CNC, I could make a big old program and go in there and take that little arch out. Bottom line is there's no good spot for a drill bit to get in with the kind of mini stuff that we got here. But that's okay, because it's not a lot of material you need to remove. So fortunately in this case, we should be able to do it by hand with a Dremel, kind of get things in there and actually sculpt the part, which is, when you're doing this like kind of little mini machining stuff, a $20 tool and an extra hour of time is going to get you exactly what you need, maybe a little bit better, little honesty. Yeah, let's hope that's deep enough. Whew. Getting hot. You gotta wear them gloves. Yeah, no, glove hand. Now I got holes. That this does not go up, so we need to cut a little angle right in there. So now I know it's going to be close there. I can see that the center of the chair is going to be here, and looks like my guess before was just right. I can start grinding that out there until we get to a good spot and sneak up on it until it's horizontal. Now we're going to try to Dremel that part away. Zone in on what we need to do for the cut. I like this old fishing box. Actually, this is an art supply box I stole from my mom. Fortunately, I went shopping. So these are pretty cheap. You can get them and, you know, keep the little guys organized. I'm going to use one of these crazy cylinder head things. See if I can do this without cutting myself. I'm going to pop this in the Dremel. Dremel out some of the material. It's got like a little cylinder head on it there. Hopefully that's all going the right direction. And then I got the circular file. I can go down there and do it by hand. I could do the whole thing by hand with this, which if you want to be precise, that's great. And we're not being precise today. You see, I've kind of ad hoc put things in there. This hole is at a different location, although it's the same distance from the bottom, but not the top right there. So that means I might need to go a little bit deeper here and whatnot. But still, that angle is going to be kind of good for me to know, and then I'll just test fit it in there until I get things working just right. So here's a little grindy bit we're going to use. Hopefully we can just kind of dig a little well in the aluminum, pop her into the Dremel, give ourselves a little room there, and lock her down. Go the right way for that, Matt. There we go. Nice. That may just be halfway there or less, but let's put it on the thing to check and see if we're getting close. All right, so this time I'm gonna actually try to put the screw in a little bit, just so we know we're exact, just enough to get it straight. There we go. And oh, wow, it's actually a good thing we stopped. Come around here. Looks like we might actually be getting close to good to go there. All right. Well, with that, I might try adding the other guy on there, but I gotta machine that out. So I got my vice grip from before, put it on the non-rivety side, get the drill on the rivety side, and hopefully not completely screw up the shot. A little bit of a burr. Doing good. Out it goes. So I'm gonna get another bolt and we're gonna try this. All right, so I got this guy in there. So we could try to mark this guy. We're gonna have to cut this bolt off to get this guy in there and probably twist this guy to get it to be a little bit more horizontal here. Looks like it got bent up a little bit when the chair broke here. You can see down here that it's at a bit of an angle right here. And that may be by design or something too. But hopefully giving it a bit of a twist isn't going to be a problem. So let's take it apart and put it back together again. Ready, Freddy? I think we got things. Really happy we stopped there with that part. But we got this guy cut down to size. Should be able to put him through there. Try to find the teeth that I made before. And screwdriver in. Alright, so I want you in there but not tight. Back off just a little bit. And then this guy, hopefully, I'll be able to bring in there. Actually, let's give this guy a little bit more of a twist.
Keep you straight. So now I'm gonna have to come around here. Kind of force you up inside there. All right. There we go. That should be where you want to live. But now, you need a tool for that. We should be good for an actual test, believe it or not. So, does the chair collapse still? It does. We got our two wonderful parts there. Why don't we take it outside and see if we can have a sit? So this hasn't exploded yet. Now's the moment of truth, though. I'm gonna try popping this out. Ooh, okay. Feels good. Give it a sit. Ah, a man upon his throne, saved from the dumpster. Good work, me.